Welcome to Khizar Choktai School of Advanced Chemistry. Enthalpy changes under standard conditions, delta H naught. Enthalpy of the lattice energy. Standard enthalpy change of lattice energy is basically the term which is used for the ionic compounds. Change in enthalpy when 1 mole of ionic compound is formed from its gaseous ions under standard conditions is known as enthalpy of the lattice energy. For example, when sodium gaseous ion and Cl negative gaseous ion are allowed to react together, then there is a formation of 1 mole of NaCl solid compound. Energy released in this process is known as enthalpy of the lattice energy of sodium chloride. Value of enthalpy of the lattice energy is always taken as a negative integer, so this is an exothermic reaction. Magnitude of the lattice energy is directly proportional to the product of positive and negative charges present in the compound, but the magnitude of the lattice energy is reverse or reciprocal to the square of the ionic radius of the charges. Next, enthalpy of formation. Standard enthalpy change of formation. Enthalpy change when 1 mole of a substance, it may be a compound or ion, is formed from its element in its standard state under standard condition. Enthalpy of formation is the term which can be used for the multiple type of compounds. For example, when sodium solid is allowed to react with a chlorine gas, there is a formation of 1 mole of NaCl, that is enthalpy of formation of ionic compound. When hydrogen gas and chlorine gas are allowed to react to make hydrogen chloride gas, it is basically enthalpy of formation of covalent compound. When hydrogen gas, chlorine gas and aqueous medium are allowed to react to make aqueous hydrogen chloride, then this enthalpy change is known as enthalpy of formation of aqueous compounds. And when there is a formation of Cl negative aqueous ion from the element chlorine and aqueous medium, then that is known as enthalpy of formation of aqueous ion. Enthalpy of atomization. Standard enthalpy of the atomization of an element. Enthalpy change when 1 mole of the gaseous atom is formed from its element in their standard states under standard conditions. For example, in case of non-metals, when chlorine molecule is break into the atomic state to make 1 mole of Cl gaseous atom, the energy required is known as enthalpy of atomization of chlorine. In case of metals, there is a just change in the physical state. For example, when magnesium solid is heated so as to make it magnesium gaseous, 1 mole of magnesium gaseous atoms, energy required is known as enthalpy of atomization of magnesium. Enthalpy of atomization can be calculated from the bond energy data in case of gaseous elements only. Enthalpy of atomization is always taken positive, so it is an endothermic process. Enthalpy of ionization energy. Standard enthalpy of the ionization energy. Enthalpy change when 1 mole of electron is removed from 1 mole of isolated gaseous atoms at standard state under standard conditions. For example, when 1 mole of electrons are removed from the magnesium atoms, there is the formation of magnesium 1 positive ion plus 1 electron. Same is the case, we can also remove the electron from the non-metallic atoms or elements. If 1 mole of electron is removed from 1 mole of chlorine atom, then once again there is the formation of Cl positive ion and there is removal of 1 electron. So this energy required to remove 1 mole of electron from the chlorine atom is known as its first ionization energy. First ionization energy, or the simply ionization energy, is positive. This is also an endothermic process. Next, delta H of electron affinity. Standard enthalpy change of the electron affinity. Enthalpy change when 1 mole of electron is added to the 1 mole of isolated gaseous atom under standard condition. For example, when 1 mole of electron is added into the 1 mole of Cl atom, energy released is known as electron affinity, enthalpy change of electron affinity. We can also add the second electron into the already one single negative gaseous ion. For example, when 1 mole of electron is added into the 1 mole of Cl negative gaseous ion, there is a formation of Cl2 negative gaseous ion. But the second electron affinity is an endothermic process. First electron affinity is always negative value, that is an exothermic process, but all other electron affinities are endothermic in nature. This is due to the greater repulsion of the electron and less attraction of the nucleus on incoming electron. Enthalpy of solution. Standard enthalpy of solution, enthalpy change when 1 mole of a solute is dissolved into a solvent to form an infinite dilute solution under standard condition. For example, when potassium chloride solid is dissolved in aqueous medium to make potassium aqueous ion and Cl aqueous ion, or it can also be written as KCl potassium chloride aqueous. Enthalpy change is known as enthalpy change of solution. Enthalpy change of solution may be positive, sometimes it may negative. Enthalpy change of the hydration energy or hydration enthalpy. Standard hydration enthalpy. Enthalpy when 1 mole of the gaseous positive or negative ion is dissolved in water to make infinite dilute solution under standard conditions. For example, when potassium positive gaseous ion is allowed to react with the water, or it is dissolved into the water to make potassium aqueous ion, enthalpy change or energy release in this case is known as enthalpy of hydration of potassium ion. Same is the case when Cl negative gaseous ion is dissolved in water to make Cl aqueous negative ion. So this energy release is known as enthalpy of hydration of Cl negative gaseous ion. Enthalpy of hydration is always a negative value. Its value is reciprocal to the size of ion. Larger the size of ion, smaller its value, and vice versa.